In this section, we move from just reading the map to actually drawing it. Objective 3.3 focuses on static routing. While dynamic protocols like OSPF are great, static routes are the manual directions you give a router. They are reliable, use zero CPU overhead, and are essential for every network engineer to master. We are going to look at the 4 specific types of static routes you'll see on the CCNA exam. 3.3a, Default Route, the exit sign. A default route is the most common static route. It tells the router, if you get a packet and you have no idea where it goes, send it here. It is often called the gateway of last resort. On a Cisco router, it always looks like this: 0.0.0.0.0.0.0.0. The zeros mean any network with any mask. You usually point this toward your internet service provider, ISP. Without a default route, your internal network would be a lonely island with no way to reach the internet. 3.3b, Network Route, the street sign. A network route is used when you want to send traffic to a specific group of devices, an entire subnet. Instead of a single house, you are giving directions to a whole neighborhood. For example, if you want all traffic for the accounting department to go through a specific router, you would create a route for their entire network, like 192.168.10255.255.255.0. This is the standard way to build a static routing table for internal office branches. 3.3c, Host Route, the address sign. A host route is the most specific type of route possible. It points to one and only one specific IP address. In networking, we use a 32-bit mask, 255.255.255.255, for this. Because it is the most specific, it will always win the longest prefix match battle we talked about earlier. You use host routes when you need to force traffic for a critical server like a database or a security appliance to take a very specific path, regardless of what the other routes say. 3.3d, Floating Static Route, the backup plan. This is a clever trick used for redundancy. A floating static route is a backup route that only appears in the routing table if the main route fails. How do we do this? We change the administrative distance, AD. Remember, a standard static route has an AD of 1. If you create a second static route but give it an AD of 50, the router will ignore it because 1 is more trustworthy than 50. However, if the cable for the primary route gets cut, that AD1 route disappears. The router then floats the AD50 route into the table to save the day. Now we are moving into dynamic routing, specifically OSPFv2. Unlike static routes where you do all the work, OSPF allows routers to talk to each other, share maps of the network, and automatically find the best path. It is the most popular interior gateway protocol used today. 3.4a, Neighbor Adjacencies, the handshake. Before OSPF routers share any routing information, they must become friends or neighbors. This happens through a very specific handshake process using hello packets. For an adjacency to form, several things must match exactly. Area ID. They must be in the same OSPF area, usually area 0. Subnet. They must be on the same primary IP subnet. Hello/dead timers. They must agree on how often to say hello. Authentication. If one uses a password, the other must use the same one. If these don't match, the adjacency will fail and no routing will happen. 3.4b, Point-to-point, the direct link. A point-to-point network type occurs when two routers are connected directly, such as through a serial link or a dedicated fiber connection. In this mode, OSPF logic is simple. There are only two nodes, so there is no need for a leader or complicated elections. The two routers simply form an adjacency and start swapping their routing data immediately. It is the most efficient way for OSPF to operate. 3.4c, Broadcast, DR and BDR selection, the meeting leader. Things get complicated when you have many routers on the same segment, like a group of routers plugged into the same Ethernet switch. If every router talked to every other router, the network would be flooded with redundant traffic. To solve this, OSPF elects two leaders. DR, designated router, the main router that everyone talks to. BDR, backup designated router, the vice president that takes over if the DR fails. The election process. Priority. The router with the highest OSPF priority wins. Default is 1. Router ID. If priorities are tied, the router with the highest router ID wins. 3.4D. Router ID, the name tag. Every OSPF router needs a unique name, which is its router ID, RID. The RID looks like an IP address, e.g., 1.1.1.1. And OSPF picks it using this logic. Manual command. If you type router ID 1.1.1.1, that's the winner. Highest loopback. If no manual ID is set, it picks the highest IP address on any loopback interface. Highest physical IP. If there are no loopbacks, it picks the highest IP address on any active physical interface. Pro tip: always set the router ID manually. It makes troubleshooting much easier because you'll know exactly which router is which in your logs. We move to next topic 3.5. In a typical network, devices like computers and printers are configured with a default gateway, which is usually the IP address of a single router. But what happens if that router hardware fails or the cable is unplugged? Every device on that network loses its connection to the outside world. First Hop Redundancy protocols, FHRP, are the solution to this single point of failure. They allow multiple physical routers to act as one single virtual router. The core concept, the virtual router. Instead of pointing your computers to the physical IP of router A or router B, you point them to a virtual IP, VIP, and a virtual MAC address. Active/primary router. One router is elected to do the actual work. It handles all the traffic sent to the virtual IP. Standby/backup router. The other router sits quietly and listens. It stays in constant communication with the active router through hello messages. Failover. If the active router stops sending hellos, the standby router immediately takes over the virtual IP. To the end user, the internet stays up, and they never even notice a glitch. The three main FHRP products. While the CCNA focuses mostly on the concepts, you need to recognize these three specific protocols. 1. HSRP, Hot Standby Router Protocol. Cisco proprietary. Created by Cisco, so it only runs on Cisco gear. Terminology. It uses an active router and a standby router. Default. This is the one you will most likely configure in a lab. 2. VRRP, Virtual Router Redundancy Protocol. Open standard. This works on any brand of router, Cisco, Juniper, HP, etc. Terminology. It uses a master router and one or more backup routers. Function. Almost identical to HSRP, just built so different brands can talk to each other. 3. GLBP, Gateway Load Balancing Protocol. Cisco proprietary. Another Cisco-only invention. The difference. While HSRP and VRRP usually leave one router sitting idle, wasted bandwidth, GLBP allows all routers in the group to forward traffic at the same time. It provides redundancy and load balancing. Key functions and terms to know. Preemption. This is a setting that allows a preferred router to take back control once it finishes rebooting or comes back online after a failure. Priority. How we decide who is the leader. The router with the highest priority, default is 100, becomes the active/master router. Object tracking. A smart feature where the router can watch its connection to the internet. If its own internet link goes down, it can purposely lower its own priority so the standby router can take over.